is also on, and it appears that it is. I'll turn the volume up. There we go. Okay, so here we are. We're going to do a practice exam to help you get ready for the exam. And so what we're going to do first is it's going to ask us to sort and rank the data on the data worksheet. What is the 107th highest value? Since I don't want to have to recreate everything if I make a mistake, I'm going to copy my data table, and I am going to use this data to do my analysis. So first it says sort and rank the data on the data worksheet. What is the 107th highest value? So since I'm ranking it, I'm going to create a column called rank, and I can give it a pattern that it will recognize, and I can drop the pattern down once I'm ready. But actually, first thing I need to do is I need to sort this. So if I want to sort the data, there's several ways to do it. One way to do it is to just select the column and go to Data Sort. If I expand this selection, it's going to keep the date associated with the revenue. And the date and the revenue do go together, so I want to expand it. Otherwise, if I hit continue with the current selection, it's going to sort just column C, but it's not going to keep column B with it, which will cause a problem for me later on. So I want to expand the selection. All right, and I'm going to sort it by revenue, largest to smallest. So at this point I have the revenue sorted by largest to smallest, so I can rank it now. So I'll give the rank a pattern, it'll recognize the pattern. And then I can just find 107, and at 107 I see that the value is 9331. 9331. Alright, the next says place the thickest possible solid blue line around cell A8. So I'm just going to right click, format cells, under here I have a border. There's the thickest line. The color is going to be blue, and I'm going to put it around the outside. Okay, good to go. What is the median revenue per day? Alright, so I'm back in this data set, and it wants the median. So I can just go right from this cell and say equals median, open parentheses. Now I'm just going to select the data. So I'm going to select the top one, go down to the bottom, shift, click, enter. My median value is 6,003. Using conditional formatting with the star icons, completely yellow is high, hollow is low. What is the highest value that has a hollow star? So in this case, I'm going to go back to my data. Here are the values. And I'm going to go to the Home tab where I find conditional formatting, where I'm going to highlight, or I'm going to use icon sets with the stars, and this has the 3 stars with the filled in star being highest, so that's what I want. Now I can just scroll down to the first place where the star is hollow, which is 4035. What month has the highest average revenue? Since it's asking for things that are going to be summarized by month, I can do this with a pivot chart or pivot table. So to do that in a pivot table, I don't need the rank anymore. So I can delete this column. I can select anywhere in the table, Control A, that'll select the values. Now I can insert, and we'll just make it a table. Okay, my data has headers, yes it does. Now I can insert a pivot table. The pivot table is going to use data from table 1. I want to spit it out right here. And in that table I want revenue and I want months. The revenue I want is the average of the revenue rather than the sum, so I'm going to have to change the value field to average. And I don't want years, and I don't want quarters, so I just unclick those and it's going to spit me down to the next level, which is months. So I'm good down to the month. Now I want to sort the values by lowest to highest. So I select anywhere in the table and I can sort largest to smallest. So it moved the months, and my month with the highest average revenue is January. January. Good. Format the value 5.45 as a currency. So there's the value, and I'm just going to click the currency button, and we're done. Create a copy of the data worksheet and rename the worksheet data 2. All right. I'm going to copy it, create a copy. Go ahead and move it to the end, and it asks me to rename it data 2. All right. Find and replace all cells in the data 2 worksheet with values less than 1,000 with the words no data. So this is going to be an if statement. So this is going to be values equal or, so I'm going to delete. So let's make sure I know if it's greater than or equal to or whether it's greater than. So I want to values less than 1,000. So I'm going to keep 1,000. So values greater than or equal to 1,000. So in this case, my if statement is going to be if these values, whoops, I forgot the equal sign. If these values are less than 1,000, give the text no data. If they are not less than 1,000, if the answer to that is false, give it a value, and I'm going to spit back out the value that's there. Close the parentheses, hit enter. So now I have the formula. I can double click that formula and it's going to bring it all the way down. Let's find a place where there's a value less than 1,000 and make sure it worked. So here's 919, so it spit out no data. So we're in good shape. As we discussed, things are probably going to work in most cases with a formula, but just to be super safe, let's copy this, Control C. I'm going to paste it as a special, or this values here. Now these are just the numbers. These are just the raw numbers. Don't have any formulas, so I don't have to worry about anything in here. And it's still going to show no data when I have no data. If I can find somewhere in here. Here we go. 396 gave us no data, but no data there was that. Now I know that it actually is the text no data. So I can use this one now to calculate what the problem asks for, which is the mean of the data set. So the mean is the same as the average. So I can say equals average. I can select the top one, go down to the bottom, hold shift, select the bottom one, hit enter, and now I calculated the average, which is 6066.825. You can also do it right here, equals average. Click on the data 2 link. Select those same values. And there we are. Next it says use a formula in cell A28 that will compute the difference between the mode in data set in data 2 versus the mode in the data worksheet. Alright, so let's just check something first. Let's find out what the mode is in the data one. So equals mode. So in the data tab, what's the mode of this guy? $18.39. Great. Now what is the mode in the other one? Equals mode in data 2 after I took out all of those values below 0. Aha, the mode is the same. So what is the difference? What's 1839 minus 1839? It's 0. So we can just say this minus that. So the answer is 0. The difference between the mode between data 1 and data 2 is 0. If you wanted to do if you wanted to do all of this work here without doing that, then you could write equals, well, let's do it. Well, you would just write equals this minus, let's just do it real quick. So here's what the value says. So equals that guy minus, I'm just going to put a 0 in here as a placeholder, right? Well, I'm just going to put that for a placeholder for right now. Equals, oh, whoops, I have two equals signs. All right, now I'm going to copy this one. And the 0 I had as a placeholder I can delete. So now I have the mode from the one data set minus the mode from the other one. And the answer is 0. So I didn't have to do it this long way. I could have just done it in one formula. So this one formula does it. Groovy. All right, on to next one. For the data worksheet, set the view to page break preview. If you were to print it without modifying anything, how many pages would it print? Now the reason I'm doing this is I want people to know how to get to these page break preview. And so if we go to the data page, and I go to View, Page Break Preview, and this is super useful when you want to know what you're going to print before you hit print on the dorm printer, because if you hit print and it's 9,000 pages, it's going to be really annoying for everyone waiting for you. And we see this goes up to page 16. If you look really closely, there's page 16. So in this case, if you were to print it without modifying any, it would take up 16 pages. Always check that before you hit print on something that's big, because oftentimes you'll have a data set and it'll just be a little bit too wide for the sheet. And so instead of printing 30 pages, it's going to print 60 pages, and they're all going to be garbage because the column that you thought fit on your page didn't quite fit. And since it didn't quite fit, it printed a whole separate page for that one little thing that didn't fit. So always check before you hit the print, especially if it's a big document. Next, we have use the unrimmed traffic light icon set in conditional formatting on the revenue data in the data worksheet with green for the higher, yellow for the middle, and red for the lower values. What revenue does the color shift from green to yellow for the first time? All right, so we're looking in the data here. I'm going to get back to a normal view. And so here are the values. And I can go to the home, conditional formatting, icon sets, traffic lights, and it said unrimmed traffic, okay? Next, what does it say? With green for the higher values, let's check and see if green are in the higher values. So I see green, yep, that's all correct. The next thing it wants to know is at what revenue does the color shift from green to yellow? So when is it yellow for the first time? So it's going to be the highest value that it's yellow. Aha, I know how to do that. I can do that by sorting these guys. So I'll go ahead and expand the selection so it keeps the date associated with the revenue. And I'll sort it by the revenue from, I can do small to large, it doesn't matter. Alright, so the first time it turns from green to yellow is here. Let's make sure we're reading the problem right. At what revenues does the color shift from green to yellow for the first time? So the first time it shifts from green to yellow is 78.44. Moving on, number 11. The following questions do not refer to a specific worksheet. What type of cell reference is indicated by the following formula? Relative, mixed, or absolute? Well, in this case, if I use a cell formula with that, it's going to be relative in the direction of the rows, and it's going to be relative in terms of the direction of the columns, so you have a relative cell reference. If I have this one, the cell is going to be relative in terms of the numbers, but it's going to be absolute in terms of the letters. So since the columns are fixed, that is a mixed reference. Down here, the columns are relative, but the rows are fixed. So that again is a mixed because one of them is absolute and one of them is relative. And in this last one, we have both the column and the row are fixed. So that is called a fixed reference or an absolute reference. Same thing. For the following if statement formula, arrange the words below with the letters A, B, and C if A is equal to 1, B, comma, C. So remember the syntax for an if statement is if the question, comma, value is true, comma, value is false. So in this case, if the question, haha, in there, the question, A is equal to 1, value if true, aha, B, this is actually in order, how neat is that? And value if false is the last one, so C. So in this case, if the question is equal to 1 and that's true, give out B, give the output if it's not true in C. Next says, given the student scores provided, write a single nested if statement in cell B52 that can be dragged down to the other cells to calculate whether a student receives a passing or failing grade. We need to know exactly what the boundaries are. So a 60 or better is passing. So I need to make sure that I'm defining things as less than 60 rather than I just need to make sure I have the equals or greater than or just greater than those situated correctly so that I can give someone a passing grade if they have a 60. And we'll be able to check that because this is a 60. So first of all, if they get 60 or better, it's passing. But if they get less than 60, it's failing. So it's easier to write less than it is to write greater than equals. So I like to keep things simple. So the first thing I'm going to do is I'm going to say equals if the value is less than 60, they are failing. And if that's not the case, there are only two choices. They could be failing or they could be not failing. So the other choice is passing. So the value, if this is true, if it's less than 60, they're failing. Otherwise, they're passing. And in this case, a 50 is failing. That makes sense. Write as students. So again, let's read the question. Write a single nested statement in cell B52 that can be dragged down to calculate whether a student receives a passing or a failing grade. So in this case, if I drag it down to 60, 60 says passing. Since that's right on the border between the two, I need to make sure I'm going in the right direction. So 60 in the wording should be passing. So receives 60% or better is passing. So this would work just fine. So that's the answer. This one doesn't need to be highlighted. And there we go. So the answer is this equation right here. We'll skip 14. We'll skip 15. Next, the following questions refer to the new link worksheet. Alright, so we have this worksheet right here. Same thing as last time, I'm going to create a copy just in case I mess something up. I'm going to bring it to the end so I know where it is. So this says, write a formula in cell I-72 to calculate the daily open stock price that occurs most frequently over the period of available data. So again, I want the daily open stock price that occurs most frequently. We talked about this before. Most frequently is the mode. So I want the mode of the daily open stock price. So equals mode and open there we go. I got the mode from the new link spreadsheet in the column of the open stock price. Write a formula in cell I-75 that calculates the average daily stock price close during 2018. So I don't want to use everything, I just want to use 2018. So I have a couple options here, but let's just do the simplest one. Equals average. I'm going to go to my spreadsheet, and anytime that this says 2018, I'm going to do the average. So the average, let's make sure I know which one it's wanting. Average daily stock price. So in that case, open, high, low, close. Interesting. Write a formula in cell that calculates the average daily stock. Oh, I close. I didn't read the last word. So we're looking at the close, and we want the average daily in 2018. Okay, so we can go to here. We're in the close column, and we only want 2018. So if we want, we can just scroll down to 2018, find the value, drag this guy down, do our shift, hit enter. So there we go. There's a formula that calculates the average daily stock price closed during 2018. If we wanted to, we could mess around and we could do some more columns, and we could separate things, and we could have an if statement that calculates only, or picks only things in 2018, and then we could take the average of just that column. This works. There are half a dozen ways that do exactly the same thing. We just chose one that we thought would be a nice, easy way to do that. Number 18, write a formula in cell I-78 to calculate the highest price the stock has reached. Well, that's an easy thing because the highest price it has ever reached is just the max. So I am just going to write an equation that says max. And in the new link data, I could just grab from the max column if I wanted, the open or the high column if I wanted, but the high here is also going to be the high of all of them, so I could choose all of them. So let's just choose all of them. And the highest price we ever reached was 58.73. Let's just check and make sure that that's the same as the max of just the max of the high column. The max column is this one. And it is. All right. In cell I-81, write a function to answer the following questions. If the volume traded exceeds 500,000, what is the average daily close price rounded to the nearest cent? Oh boy, I see the word if, which tells me I'm going to need to do an if statement. So the first thing we want to do is we want to find out if the volume traded equals 500,000. So the only data we want to use is if the volume traded equals $500,000 or more. So equals if this is less than 500,000, comma, I'm just going to do no data. And if that is not true, then I'm going to spit out, what did it ask for? It asked for the daily closing price, which is in column E. Whoops, what did I do here? So if that cell, if the volume is less than 500,000, do no data. But if it's not, if it's 500,000 or more in volume, I'm going to pick the closing. If F2 is less than 500,000, no data. Otherwise, I'm not seeing what I did wrong. Let me try this again. Computer's frozen. Well, that's not good. Well, the computer's frozen, so I guess we will have to open up a new tab. I wonder why that happened. Oh, there we go. Maybe. Let's start over. For some reason that just wasn't happy. We're going to just start over. Equals if the volume is less than 500,000, no data. Otherwise, give it the closing. Great, so now we have this. Again, we have these equations. We think it'll probably work with the equations, but let's just, to be extra safe, let's copy it, let's paste the values here, and now we know for sure we have no equations and things won't get messed up, so now we just have the data. What's the exam say to do? The exam says, write a function to answer the following. Oh, I have to write a function. Ooh. But let's just do this. Let's follow this through and get the answer, and then we can write a function. Write a function to answer the following question. If the volume traded exceeds 500,000, what is the average daily close price rounded to the nearest cent? So now we have to calculate the average. And so in this case, we can say equals average of the values here. And it wants it rounded to the nearest cent. And if I want to round to the nearest cent, that is a function that I can use in Excel. So I can say round, and it'll say, okay, give me the number to round to the number of digits. Let's say I want to round to 1 digit. Let's see what it'll look like. Aha, 20.2. Well, that's not going to work because that's rounding to the nearest 10 cents. So if I go 2 digits, there we go. Now I have a function that is calculating the daily close price rounded to the nearest cent. So there we go, $20.21. Since it asked me to write a function that does that, I am not just using the arrows up here. I'm actually having the function compute the rounding. Number 20, in cell I-84, write a function to answer the following question. If the difference between the high and low price is greater than 0.5 and the volume is greater than 1,000,000, what is the average daily closing rounded to the nearest cent? So this was the hardest question on the exam, with the goal of really seeing who was able to play around with these sort of complicated nested if statements, and let's see if we can figure it out. Write a function to answer the following questions. If the difference between the high and low is greater than 0.5. So there we go. We have an if statement if the difference is greater than 0.5. So here we are. First thing we're going to do is have a difference and equals, I'm just going to say the absolute value of one minus the other, so I don't have to worry about whether it's plus or whether it's minus. All right, the difference is 0.14. Let's make sure we're answering that correctly. The difference between the high and low is greater than 0.5. So now I have a column of difference. The next is it wanted me to know when my volume was big enough. So the next one, the volume is greater than 1,000,000. So in this case, so this is volume greater than 1,000,000 equals if the volume is greater than 1,000,000, I want to give it this difference. Let's give it, actually, what is it asking for? It's asking for the difference between the high, what is the average daily closing? So in this case, oh, I'm messing myself up here. If it's greater than 1,000,000, give it the daily closing. Otherwise, give it no data. Now in this case, what it's going to do is it's only going to give me data when the volume is over 500,000, and in that case it's going to spit out the data. So now I have data in this column when I meet the volume over 1,000,000. I have data in this column when the difference is greater than, did I just calculate the difference? Yeah, I just calculated the difference. So I want to do, what did the problem ask for? It said if the difference between the high and low is greater than 0.5. So next, I keep doing that. We're only going to use the data if the difference is greater. So in this case, is the diff great enough? So the question is if this is greater than 0.5, give me the volume at close. Otherwise, give me no data. Okay. So now there are cases where I have data in this one but no data in this one. And there are cases when I have data in this one and this one. And there are cases when I have data in this one and not this one. So the only thing I want is I only want when there are data in both of them. Okay, so let's read this one more time. If the difference between the high and low is greater than 0.5 and the volume is greater than 1,000,000, what is the average? Okay, so I'm here. Now, right now, these are the no data. I want to show you just a way to do this, a simple way to do this. I'm going to copy both of these, and we're going to do that same trick where I'm going to paste special as values. And now I can do Control F, and I can change all of the no datas to 0. Now when I replace all of the no datas with 0, if I multiply any number by 0, I get 0. So if I create the product of these two columns and I get 0, I want to disregard it. Otherwise, I want to take the average of the items that I have left. Or I want to get the close. I want to get the closing price, and then I'll take the average of that. So in this case, we want to say equals if this times this is equal to 0, no data. But if that's not the case, spit out the average close. And now I can drag that baby down. And then the question is, what is the average daily close? So from here I can say equals average Alright, so now we have the average close and we want it rounded to the nearest cent. So equals round and comma 2. So it's going to round it, and there we go. So now we have all of these if statements nested together. We were able to figure out what all these different if statements meant, and we were able to calculate the average daily closing price rounded to the nearest cent when the volume is greater than 1,000,000 and the average high and the difference between the high and low is greater than 0.5. So when might you use this? Well, if you are a stock trader and you've created some really newfangled approach and you think you can time the market by checking and only buying stocks when all of these conditions are met, this would be a way that maybe your formula for success is that, hey, there has to be a lot of variability, so we need the difference between the high and low greater than 0.5, and it needs to be on a day when a whole bunch is trading, so we need a lot of volume, and that is, that's what we're looking for. So in those cases, what's the average? And so this might be something you could use as a stock picker if you felt that you could do that effectively. Next, plot the daily high and low values for March 2018. Label the y-axis. Make the high values have green circles with green line connecting the values. Make the low values have red circles with red lines connecting the values. Okay. We're in the new link data, and we want the highs and lows. So I'm going to do a little trick here to make this easier. I don't want to lose this value, so I'm just going to move it over. So now I have the date right next to high and low. The next thing is that it says is plot the values for plot the daily high and low values for March 2018. Now I could do it with the whole data set, or I could make even one more simplification, and that would be to just select the values from March 2018. So let's take the easiest approach. Alright, and here's March 2018 with the high and low. I'm going to copy that. I'll make a new tab. This is date, this is high, this is low. Now I have a table. I can just select my table here, insert. Let's see what it recommends. Let's just plot this in and see what happens. Oftentimes the recommended chart is exactly what you want, and in this case, bam, there we go. That looks really, really good. So let's go for it. Move this thing out of the way. Alright. So now in this case, it wanted, let's zoom in a little bit. the y-axis in this case is price. Share price in dollars. We will pull this up here. This is kind of a wide range, so let's just play around with the axes a little bit to make sure that we have it how we want it. In this case, the minimum looks like it's never less than 6. Let's see how that does. Ah, that looks pretty good. Now these we want to be red for the low, so we can change the colors. And we wanted a certain, what else did we want in that? We wanted the symbols to be another color. And this one we wanted to be green. Alright. So right now it's labeling as series 1 and series 2. If we go to select data, we can change the axes titles. So chart name, high, and for this guy, the low. Okay, so now we have high and low. We make this look a little bit nicer. High, low, so this is March 2018. Stock. Daily stock range, something like that. Now the last thing we need to do is it asks to have the make the high values have green circles with the line. So we want to add the symbols for each one of the dots. So since the chart that we chose doesn't have the symbols in it, where am I here? Where's my sheet? There it is. So the chart that we picked only had the lines. It doesn't have the dots each time there's a symbol. So we're going to have to figure out how to do those symbols. And I bet we can figure that out by picking this thing, marker, and we're going to do a solid line that is green, and it is going to be somewhere in here. We're going to be able to find a circle. Here we go. So there we go. So now we have that one, and on this one we can make this a circle. And it's going to be red. Alright, so now we've done, the last thing, it looks like on our markers here, we have blue going around the outside, so we just need to fix that, which is down here, and that's green. Alright, so now we have exactly what it wanted in this chart. If we want to make it look pretty, we could make it look pretty. We could take off these. We could format the axes a little bit if we wanted to, make it look a little bit better. But there we go. There's the chart that it was looking for. Next it says create a clustered column chart of high and low daily values for March 2018. The x-axis must show the date A legend must be used to distinguish the high from the low. The chart title should be appropriate. The major grid line should be removed, and all the text should be Arial with 10-point font. All right, a clustered column chart. So let's go back to that same set of data. And go Insert. And we want a chart. Now if we look at these, clustered column, there we go. So the first one has what we want. So let's go ahead and select that. Next thing, create a clustered column with high and low. The x-axis must show the date every day. The legend must be used to distinguish the high from the low. The chart title should be appropriate. The major grid line should be removed, and all text should be Arial 10 font. All right, we can do all that. So in this case, right now, we only have the 25th and then the 27th showing. So we need to make it wider so that every single day is showing. All right, now every day is showing. Currently, we're not showing the axes titles. So if we do I'm going to select data, and again I'm going to add the series. So in series 1 the name is high, series 2 the name is low, alright, it wanted things labeled appropriately. So in this case, add a chart element, the axis title, primary vertical, this is stock range, daily stock range. And this is March 2018 daily stock range. And it wanted the major grid lines removed, so we can remove the major grid lines. So now we're showing every single day. We have a legend that's showing the difference. We can make that legend look a little bit nicer. If we like those colors, we can leave those colors. If we want to do green and red, we could change those to green and red. But that's what we promised we would deliver, and there we are delivering it. So that gets us through 22, and that is about what the expectation is for what we're going to be doing. However, we are going to be doing some pivot tables and pivot charts. This last section is a little bit more complicated. It's going to take a little bit more time, but you will have 2 hours for the exam, and on that exam you're going to want to be able to do the level of stuff we've done, adding in a few relatively simple pivot tables and pivot charts to summarize information. So I hope that gives you a good idea of what will be on the exam, and I will stop recording here and I will upload this to YouTube. So it took us 48 minutes to get through that. So I'm guessing I'm probably working at least twice as fast as you guys are, so there probably won't be too much more content in the final exam. It'll be about that amount of content, but there will just be the addition of some pivot tables and pivot charts.